Okay, this is part 2 of our October 31st edition. And as I promised, we'll do one more trig equation. We're going to solve a trig equation, and this one is going to be 3 tangent squared x minus 1 equals 0. So, with that, we're going to look at, sorry, my chair's a little high. You're going to have the headless teacher in honor of Halloween. Alright, 3 tangent squared x minus 1 equals 0. And we're going to solve that. We're going to find out what values for x will make this statement true. And to do that, our first step is to get tangent x by itself. So I'm going to pull the 1 over by addition and divide by 3, just as if it was any old equation. And then to get tangent by itself, right now it's tangent squared. I'm going to take the square root of both sides. And that will undo that square and give me just tangent on this side. And plus or minus, whenever you take the square root of both sides, you get square root of 1 over 3. Cleaning that up a little bit, square root of 1 is 1. So I can write it 1 plus or minus 1 over the square root of 3. Now that one I usually rationalize my answers, but remember I'm looking at the unit circle to help me find what angle has a tangent of 1 over plus or minus 1 over the square root of 3. So my unit circle is best examined if we keep it in this form. So tangent, you'll recall, is the second coordinate divided by the first. So I'm going to look in the first quadrant at one of my sixth. So this one was square root of 3 over 1/2 up. Square root of, this one was 1/2 over square root of 3 up. Square root of 3 over 2, up. So it's probably one of those. So in your thoughts, whose thoughts shall we grab? Let's grab Maggie's thoughts. There's Maggie's thoughts. And she's thinking, if I divide this by this, will I get this? 1/2 divided by square root of 3 over 2 means to flip it and multiply. And I do get 1 over the square root of 3. Alright, so we found the spot right off. It was pi over 6. So pi over 6 is one answer. So we have x equals pi over 6. But recall, we can go, instead of stopping here, we can go around again and get on and around again, and we can get more answers. So we decided to deal with that by saying plus 2 pi n. Now this one, I have another way of doing. I can actually make this more concise than even this. So we'll see how that pans out when we find other answers. So I'm going to go over here to another spot and over on this side where the same thing might happen. So if it happened there, it'll probably happen here. And the coordinates there are negative square root of 3 over 2 over and 1/2 up. And the second divided by the first is the same as Maggie's thoughts, except it'll become out negative. But we have a plus or a negative here, so negative works. So we found another spot, and that spot right there is 5 pi over 6. And we're going to do 2 pi n for now until we find a better way. Alright, so there's another one over here where we go back square root of 3 over 2, so that's negative, and down negative 1/2. This divided by this is the same as that, and so that's another one. X equals 7 pi over 6, and we can spin that one around and around and get lots more. And lastly, it'll be 1 over here. And you can verify that. It's 11 pi over 6 over plus 2 pi n. Now the only thing about these is I can write those, instead of writing 4 answers plus 2 pi n, you might notice that these two are quite related. The pi over 6, this one and this one are related along this line. So I could put those together and say the first one, pi over 6, and to get to the second one, how many radians would it take to get to this one? It's not 1 whole circle away, but half a circle. So we could catch this one with this expression and say plus pi n. You see how that would take this one at pi over 6 and rotate it half a circle. Then we grab that one. And that n will have us keep grabbing the rest of the spinning ones. So this one will take care of this one, so we don't have to write it anymore. Do you see also how this one, I didn't draw it very clear, but these are exactly across from one another as well in a straight line. So I can take this one and do what with it to catch this one and all the other rotations. So I can start from here, 5 pi over 6, to grab this one, I go over pi n. And then that will take care of all the additional ones. So goodbye. All right. It didn't work out that way on the first example because it didn't turn out that the answers were, the root solutions or answers were exactly pi radians apart from one another. So you can look back at that example and see. So here are 2 answers to this trig equation. There we go, snazzy again. If you plug in any of these answers into this equation for x, and you take 3 tangent squared of that value minus 1, you will get 0. All right. We're going to practice these together in class, so make sure you get this down, and maybe I'll just leave you, I'll just skip the part where I leave you an equation to solve, and I'll give you plenty tomorrow to make up for it. All right, till then, the headless teacher is over and out.